Okay, it's recording. So, hello guys, welcome to our first. I don't, is it the first session? I think it's the first session. But yeah, welcome to our first session, Informatics 1B students. So we're going through a past practical, and this past practical, I'm doing it so that you guys have an idea, or you sort of like have a clue on how to approach this next week's practical. So this is a previous practical, right? But then it's similar to what you're required to do for your practical. So let's begin. So what is iterative and what is recursive, right? So iterative iterative is basically is so both of them we can agree that both of them, right? Iterative plus recursive, both are meant for doing repetitive work, right? If you are doing something that needs to be repeated a couple of times, then you either take the iterative approach or the recursive approach, right? So I won't go into the extra details, but then just know that if it's iterative, there's for loops involved, right? If it's iterative. So if it's iterative, then there's for loops or while loops, just loops in general. Then you know it's iterative. If it's recursive, just know it's either a subroutine or function. But then most of the time, we're going to use a function because we expect to get a value, right? We expect to get back something. So we're going to use a function. A subroutine, you still can achieve something similar to that, but then it won't work as intended. Recursion or a recursive approach, it requires a function. So I just say the subroutine there because it's still possible. But then we mainly use a function. So we have this out of the way, right? So let's make a simple example, right? So let's say I wanted to create a for loop, right? To add numbers from 1 to 10, right? Something like that. Let me open Visual Studio. I feel like it's best to demonstrate with Visual Studio. So let me create a new project. And then select Windows Forms app .NET framework, right? We want the .NET framework. Okay, so let's give it a name. So let me just say, okay, let me select the folder that I want to save it in. Computer Science Informatics 1B perks. There we go. Um, let me just save it as iterative. So with the iterative approach, right, we're gonna need a for loop, right? So let's just make a simple application, right? So let me uh, take a button here. So when the user selects the button or clicks on the button, a specific event is triggered, right? So we need to respond to the user, right? We need to give back something to the user when the user clicks the button. So we need to handle that event. So I double click on the button so that I can use the button. So let's start, right? Let's start making the application. So our application, just keep in mind, my application will use what we call local variables. That's what my application is going to use. Local variables, not global variables, just for the sake of simplicity. Or even it might not even use any variables at all. Yeah, I don't think I'll use any variables, but let me just leave it like as is. So I want to create an application that sums up numbers from 1 to 10, right? These are the numbers that I want to sum up or that I want to add up, right? So I want to add from 1 to 10. So let me quickly do the arithmetic and see what output should I expect. 7 plus 8 plus 9 plus 10. So my output should be equal to 55. That's what I'm expecting. So I'm creating an application where I'm going to sum from 1 to 10. And then just know that the step is going to be 1, right? So like 1, 2, 3, 4, and so forth. So let me just write it like that. 1, 2, 3, comma, dot, 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 up until 10. So I'm going to add up those numbers from 1 to 10, meaning the step is going to be 1. I'm going to increment by 1 or increase by 1 to get to the next value, right? As you can see, I started from 1 and then I increased by 1 to get to 2. And then from 2, I increased by 1 to get to 3. That's what you mean by step. You're increasing the current number by 1 to get the next number. That's what step means. You can either increase or decrease. In this scenario, we are actually increasing, right? So let's do that. It's a simple what? For loop. So I'm gonna use a for loop and say for I as integer, right? Is equals to 1 to 10. And then next I. I don't need to say next I, but then I just like putting it there. So my application is summing or adding up numbers from 1 to 10, right? Simple application, straightforward. But, oh yeah, I'm going to need a sum. But I'm going to need a variable, a local variable. So I need somewhere to store the sum, right? So let me do that. So I'm going to say dim sum as an integer because I'm dealing with integers, right? I'm just going to initialize it to 0 at the beginning. It's going to be 0. And then now let's add up the values, right? How do we sum up these values? It's simple. I just say sum is equals to sum plus I. Why is this possible? This simple formula is possible because this equal sign, right? When you look at this equal sign, it doesn't mean left hand side is equal to right hand side, like in your mathematics class. That's not what it means. This one means we are assigning. It's called an assignment operator. We are doing an assignment operator. We are assigning this variable or this box to the value on the right-hand side. So if you look at the right-hand side, right, I have variables. How will it know that I want values? Well, the way it works is that these variables, right, they serve as labels for your boxes, right? Remember, these variables are just boxes. Imagine if you went to Pick and Pay and you wanted to any shop of your choice. It doesn't have to be Pick and Pay. You went to a shop, right? In my example, I'm gonna use Pick and Pay. You went to Pick and Pay and you wanted to buy Stay Soft. And when you get there, you find containers that look exactly the same as Stay Soft, and all of them are in one aisle. They're all white with no label. What are the odds that you're gonna pick up Stay Soft? They're quite slim. They're very slim. They're very low. The chances are very low. So that's why labels are very useful so that it's easy to understand what is in order to remember or to remember what you placed inside that container, or so that when another person goes to that container and they see the label, they'll be like, oh, so inside this container, this is a container for example, stay soft, because on the outside it's written stay soft, right? So I'll know I'm picking up stay soft and not something else like sunlight liquid. because those things are quite similar in texture, right? So you can by sunlight liquid, I mean the one in sachets, right? So think about the one in sachets. If you want to buy that one, it might be similar to Stay Soft. So you want to be sure that you're picking up the right one. How do you know? Labels are what helps. And then when it comes to data types, integer for the computer, right? Integer helps the computer know what are the contents, or what are the type of contents or type of things that can be placed inside that box, right? So I'm just speaking, but then some people cannot really visualize. So let me help you by visualizing it, writing it down. So by box, I just mean this box. I just mean this box, right? If I have two boxes like this, right? They're identical. It can be, let's give it life. Let's make it, yeah. Okay, that's not the one. Okay, yeah. Green is fine. So look at these boxes. Can you tell what's inside? Imagine they're sealed. Can you tell what's inside? Now imagine there's 4 million of these boxes, and you're looking for something like a pencil, your pencil. Let's say the boxes are in the garage. You have a big garage. You have 4,000 boxes. How long would it take you to find that pencil of yours? It might take even years to find that pencil, because first of all, you're going to be demotivated because you don't know which box has what. You might be lucky by chance, and very first box you open, you find a pencil. But then we don't want to deal with luck here. Luck is a very rare phenomenon. How do we help the computer distinguish from these boxes? By giving them labels. So this box will be called sum, right? And then the computer knows, oh, so this is a label named sum. So that when you refer to it, it knows, oh, you mean that box. And then this one is going to be called I, right? I for the loop, right? If you remember, we have I for the loop. So since we have I for the loop, you also need to tell it what type of data can go inside the box. What tells the computer what type of data goes into the box is the data type. It's even in the name. Data type. So reverse these words, what you get, type data, right? Type data, that's what you get, right? You get exactly this. But then put a space and then put off. You get type of data. That's what data type in essence stands for. So data type, it means what type of data goes into the box, or what type of things. The computer calls it data. Data meaning your age, your height, your surname, your dislikes, likes, characteristic, all those things. That's what we call data. So to help the computer distinguish what type of data is being stored, you need to give it a data type, because each data type, right? Each data type is accompanied by a value and a set of operations that are possible for that data. You cannot get someone's name and try to divide it by two. Does that make any sense? That's what I mean by operation. Operation, the things that you're able to do, they are the ways you can operate on the value, right? The way I like to view operation, right? I like to think of it in terms of a doctor. Think of a doctor operating. Yeah, let's use the doctor analogy, right? Operations are analogous to, or they're similar to doctors, right? A doctor specializes in some type of operation, right? So, for example, let's look at doctors who are specialists, right? We have a doctor who specializes in doing surgery for the heart, right? They are, I don't know the terminology for it for them. I'm not a doctor. But then I know each doctor has some doctors, right? Not all of them. Some doctors end up specializing, right? They specialize. So imagine you have a doctor who specializes in doing heart surgeries, right? There's certain things you can do, or the certain ways you can operate, or yeah, certain ways you can operate the heart, right? But then the way you operate a heart won't be the same way a doctor who specializes in operating legs will operate the heart. Those two things are different. You can't operate legs the same way you operate the heart, if you get what I'm saying. And vice versa. You can't operate the legs the way you operate the heart. So that's why I say each data type has a value. In this, a value can be that thing itself, right? Let's say, for example, the heart. Operations is how you operate on that heart. So each doctor has a specific specializes in a specific part of the human body. So therefore, when the doctor for the heart does a different operation, the doctor for the legs does a different operation. So that's how I like to view it. And I hope you can view it in that way. So for example, you've told the computer, okay, sum. So when you say sum as integer, this is what you mean. So you're telling it that the label is sum, and then you're adding extra information, right? The extra information is that you're telling it you can only accept integers. That's what you're telling it when you put the integer data type. You're telling it, listen, your label is that, right? It's your label is sum. And then the content is okay, let me phrase it the right way. Let me do this. Let me put here, let me say the label. What is the label for this box? The label is sum, right? We can both agree on that. The label is going to be called sum, right? Let me edit there at the top, and then we add this. And then content, right? Content, if you don't understand the word content, you guys are used to social media. What type of content do you post to show me? Things like that, then your friend will be like, no, I post mukbangs, I post about food, I do food reviews like Keith Lee, you know, that's content. What type of thing? What type of thing is there? So in this case, what content is what is the type of thing inside the box? So this one has integers, right? Integer, meaning that can only accept integers, right? That's what it means when you use that data type integer. So let me expand this a bit. Yeah, so this is what it means. You've given it a label, it's sum. Content is the data type, which is integer, which tells it, oh, you can only accept integers. So what would happen if you try to store, let me see. Okay, there's no, but then what would happen if you try to store the string hello world inside? Let's say you try to do that, right? There's the string, and then you try to put it inside the box, right? You try to put it inside the box. What would happen? Well, your computer is gonna scream at you and shout at you and be like, what are you doing? We had an agreement. You told me that this box can only accept integers or numbers, right? But then integers, meaning it's a non-decimal value. So integers, it can only accept integers, right? But then what is this now? What's that? I don't know what you expect me to do with that. It's like what's happening right now. It's like you're telling the doctor who specializes in operating the heart to go and do an operation on legs. It's gonna be like, well, this is not my field. I don't know what to do, so I'm just gonna shout at you and be like, what is wrong with you? Because it's written right there that this is what I do. I operate on the heart. This one is written that I can only accept integers. So why are you giving me strings? So let me show you here. Let's do that. Let's add a string here. Hello. Well, I don't know why it doesn't underline. So, I'm expecting it better scream at me. Okay, it doesn't. I don't know why it's doing that. But then it should scream at you. But then technically, I know why that could be the reason. Yeah, technically I know why that could be. So let me do this. Let me do something spiritual. Let me try to sum up. Oh, I see why it wasn't complaining. Visual Basic is weird. I must click the button first. So let me click the button. Now it's gonna scream at me. You see, exception handling, right? It says conversion from string to type double is not valid, right? I don't know why it's saying type double, but from that type int, it was supposed to say integer because I'm dealing with integers here. So it's telling you I couldn't convert to that type. Basically, it's screaming at you, telling you this cannot go inside that box. This box sum only accepts integers. Why are you putting in hello world, the string? I don't know what to do with that. So you have to put in a number like one. When you put in a number like one, then oh, okay, that's acceptable. So let me put the one inside the box. So that's all about variables. I just wanted to clarify that. So since we now understand variables, right? What does this mean? So when it's on the right-hand side of the equals sign, right? This equals sign, if it's on the right-hand side, you're telling the computer to go and open that box and take what's inside the box. It's as simple as that. So when you say sum is equals to sum plus I, you're telling it, oh, go to this box. What's there inside sum? Oh, there's currently one. And then add it to whatever is currently inside I, and then sum them. Take whatever's inside the box with the label I, add them up, and then put the new value into the box with the label sum. How do I know that I'm going to put it back into the label, into that box with that label sum? Because I see this equal sign, and then on the left-hand side, I have sum. On the left-hand side, it's the label of the box you're going to put this new value into. So since it's like this, right? You see, look at how it is here. The way it is here, I'm going to keep incrementing or increasing the current value inside the box with label sum. Why am I saying so? Because on the right-hand side, there's sum, and then I'm going to add to that the current value inside sum, add the current value of I, and then put it back into sum. And then again, I take the new updated value inside sum, I add the current value of I, and then I put it back into sum. So I keep on increasing and increasing and increasing the value inside sum. So we have that out of the way. I just needed to explain that. So let's I hope it doesn't shout at me to convert it to a string. It only accepts strings. So oh, okay, I'm not using the option strict on. That's why it will do it on my behalf. But then the moment I put option strict on, then it's gonna have a problem. As you can see, it's 55. We expected the answer 55, which is correct, right? So that's correct. So this is a problem. You must always put your option statements, right? We have option strict on. Option strict on, it means that it's going to be strict in terms of casting. And then option explicit on, it's just going to be explicit, right? You need to define your variables explicitly. By explicitly, they mean that you need to also define the data type. Because you could just say dim sum is equal to 0 and or private sum is equal to 0. Then it could come up with a data type. That's how smart it is. But then since you guys are beginners, we want you to write everything from scratch. So we have option infer off. Option infer off is basically it's basically linked to local variables, right? You need to de explicitly define your local variables. So it turns it off so that you have to explicitly write that this I need declaring a variable and is going to be of this type. If it wasn't the case, you would write something like this. You just say sum is equals to 0. You'd write that if it wasn't the case. But then now we have option in fair off. It's gonna moan at you and be like, okay, why are you doing this? Don't do that. So yeah. So this should be a problem. I don't know why Visual Basic just is so lenient. Try doing this in C++ or C. You're gonna have a serious problem, or even Java. Okay, yeah, all of those languages, they have those issues. So I remember the message box only accepts a string, right? And remember, I've turned on option strict on. I'm sure it was gonna scream at me when I click the button, but it's fine. So let's do this. So we have 55. We are still on the right track. So now let's put a second button, right? So I'm gonna copy, paste. You do know you can copy paste, right? You don't need to drag and drop the buttons again. So we have this, right? This is the recursive approach. So for recursive, we need to create a function, right? Remember what we talked about in the notepad, in our notes, right? We said recursive uses a subroutine or a function, right? It's still the same. It's literally this, right? It's literally this. But then there's a small difference between the two. We'll say this one uses less space, right? By space, it means like your space in your phone or your laptop in this case. Remember, for those I'm sure a lot of all of us have had an Android at some point. Yeah. So imagine that Android that you once had and then it ran out of memory and you're trying to download an image or just a video and it says storage, what that's complaining about storage. Well, this is the best approach because it doesn't use a lot of storage. This one that I'm about to write now, the recursive approach, it uses a lot of storage. So be very careful with the approach. But then sometimes one is better than the other. It just depends on the problem you're solving. So private function, right? I'm gonna call it sum, right? And then it's gonna take in by value. Um, the in this case, we're gonna say n, right, as integer, and then it's gonna return an integer as integer. So let's see. So the integer that is gonna take, right? Okay, okay, let me tell you the way we're gonna approach this one, right? If you look at this, the way we approached this one, we started from 1 and we went up to 10. For the function, we're gonna most of the time, yeah, usually, yeah, we're gonna start from the top, meaning the last number, which is 10, and then work our way down to the number to 1, right? So that means n, when I pass in n, I'm gonna say n is 10. I'm gonna pass in 10. And then I keep on decreasing by 1 and then adding and adding. Because either way, it's still the same thing. If I add starting from 10 going to 1, I'll still get 55. The direction doesn't matter. What matters is the values that I'm adding up. So that's what I'm going to do. That's how most of the time it's going to work. So this n is going to be the last number, which is 10. So let's do that. So what's the formula? Let's sit down and really think about it. What's the formula? If you look at the formula, right? If you look at the formula, right, it says the current value of n, right? Okay, since we are looking at it from this perspective, right? We are looking at it from this perspective where we're starting from 10. So 10, 9, 8. Okay, let me just write it like that. right? So it's in that order. So if you look at, let's assume, remember we said n is going to be 10, right? So if n is represented, if n is represented by it represents the value 10, then we can say this is n, right? Plus, how do we find 9 if n is 10? We simply subtract 1 from n. So it's just going to be n minus 1, right? And then how do we get the next one? It's just the previous one, which is this, minus 1. So it's going to be n minus 1 minus 1. And then if you look at this one, what is minus 1 minus 1? It's just minus 2. So now this is going to be minus 2. And then it goes on and on and on until we get to 1. So that would be of our hint, right? So if you look at it, the main important thing here that we need to note is these two cases. This is what we're gonna call the recursive case. The recursive, the thing that's gonna keep repeating. And then our base case, right, is when does it stop? It stops when it equals 1. When n is 1, that's when it stops. So we're starting at n, and then the formula, I need to take the current value of n and then add the next element, which is n minus 1. So how do we do that? But then remember, I need to again call the function. Another term for recursive or recursion, right? Another way of describing it is a function calling itself, or a function that calls itself. That's just recursion. So we need to we need to call this function again and again and again and again, repeated. It's so remember, we're trying to mimic this. That's our goal. So how do we do that? We already found out the sort of like general term in a way. So this is how generally we're gonna solve our problem, right? So n plus n minus 1. So I need to have my recursive call, right? Or recursive case where I'm going to what is this? Keep on calling the function. So I need a formula. What's the formula? It's n, right? Plus, and then I have to, you see now the tricky part is you can't just say n minus 1. That's the problem. Why am I saying so? Because if you leave it like this, what's going to happen is just going to say 10 plus 9 and then give you the answer, and then it stops. And then that's it. That's a problem. So what I need to do is I need to call the function again. So I need to say 10 plus, and then I call the function again, the sum function of 9, right? And then 9 is just going to be 9 plus 8. And then I call the sum function when the value is 8, and so on and so on and so on. So I'm going to have this, and then I'm going to have, what's the sum of 9? It's basically 9 plus 8. But then I don't want to stop at 8, so I need to continue. I'm going to call the function when the value is 8, and so on and so on and so on. I end up building up the full thing. So it ends up, let's build it up so that you can see. So it ends up being 9, and then what's the sum of 8? What's the answer when you call, remember the formula that I'm using, it's this one over here. So don't get confused. I'm using that formula, n plus n minus 1. That's the one I'm using. Okay, I think it's gonna give me problems if I don't make them comments. Let me make them comments. Yeah, so it's going to have this, and then what is sum of 8? What is the function when you call the sum function and we pass in 8? It's going to be 8 plus 8 minus 1. So it's going to be 8 plus 8 minus 1, which is 7, right? Which is 7. So it's going to be 7, but I still need to call the function when the value is 7. So I'm going to say sum of 7. And then I keep on doing the same thing. Eventually, I will get to 1. Right? I don't want to write that long thing. I have a diagram prepared, right, for this practical. I did the diagram for this one. It's a bit shorter than compared to this one at the top. So I'll show you a diagram. You get to see it visually. So this is sort of like the pattern that we're looking for. If you look at it, what's the pattern is I take the current n value, right? Plus, and then I call the same function within my function again, and then I pass in a parameter. Look at this parameter. How did it change? I just subtracted 1 from n. So basically this part, I'll just have to say sum of n minus 1. And then this is what I have. But then the problem, when we still haven't solved it, we only have now what we call the recursive case or the recursive call, right? Basically, the part whereby it's going to keep calling itself and it's keep calling it over and over again. The part that's basically the part that's going to be repeated, right? That's the recursive call. That's what we call the recursive call. But then it's going to keep repeating. But then do you see that it eventually doesn't stop? So since it doesn't stop, we're going to have an issue. That's where the base case comes in place. What's the base case? It's basically when should we stop? We should stop when you see that n is equals to 1. That's when we should stop. If we look at it, when n is equals to 1, that's when we should stop. So every time before we even execute it, we need to check. Look at where I've placed the if statement. It's also very important where you place the if statement. So I need to check first, is n currently 1? If it's not currently 1, then you should go to this recursive call. But then in your slides, they did it this way. They said else. So they used an else. So they did this, which is perfect. It's easier to understand. So let's do it this way. So how does this way works? It starts by checking if n is equals to 1. If it's not, then repeat. Call the function. And then don't worry about how it knows. There's this thing called the stack. It uses the stack. I'm sure you guys will learn it. It's there in the slides. Yeah, it uses the stack. The stack, you can just imagine stacking plates on top of each other. That's how it works. And you're gonna see our diagram that it sort of looks like plates stacked on top of each other. So it uses the stack to remember all of these calculations. So when n is equals to 1, what do we expect to get back? What do you think should be the sum? The sum should be, if I say 1 plus the sum of 0, right? Because 1 minus 1 is going to be 0. What's the sum of 0? It's just going to be 0. So 1 plus 0 is just going to be 1. So therefore, I'm going to return 1 here. So it's going to stop when it sees, when n is equals to 1, it's going to stop and return 1. What happens is, remember, it's still not done. What happens is when it's returned 1, it keeps on substituting back to those answers that it stored in that stack until it gets to the final answer. You'll see with the diagram, it sort of like it kind of looks like magic. You'll see with the diagram. So we have this, and then now let's call our function there. And it's simple. I won't even create a variable for it. I'm just gonna say msg box or message box convert to string. What am I converting to string? Whatever is returned by me calling the function sum when I pass in the value 10. Don't let this confuse you. Remember this function is supposed to return a value. So whatever is returned, in this case, let's say it's going to be 55, right? Convert that 55 to string, then output it using a message box. It's as simple as that. You don't need to have any extra variables. If you feel like it's a bit too much, you could declare a variable. But then I'm just gonna leave it like this. So let's run it. Let's test both ways and see if we are on the right track or there's still something we need to fix. So the first approach, iterative, right, which is for loops. I decided to use a for loop. You could use a while loop, but then a for loop is pretty straightforward. So we have 55, right? That means that's the output we expect. So if you want to be if you want to be 100% sure, you need to start with iterative so that you know what's the answer that you're expecting. And then perfect. You see, I know it looks like it's magic, but yeah, it does work. It's exactly the same answer. It's going to be 55. So we have solved it using the recursive approach and the iterative approach. So with that being said, I don't want to make this video long. I want to divide it into many parts. I don't know how long this video is now, but then I'm sure it's like 40 something minutes, around plus or minus an hour. So I'm going to stop here and then we're going to start with the actual practical. I suggest you watch every single video from start to finish so that you really understand what's going on. We are breaking it down. I really want to break it down so that you can picture it. I think you're also going to have, yeah, you're going to have this in the exam. You're going to need to draw the diagram. I think even the semester test. Yeah. So you need to know the diagram. Besides you knowing the function and the how to implement, you need to know the diagram. So yeah, I'll see you in the next video. Let me just stop it here. I don't know how long it is. I don't care. I don't want it to be too long because I know you guys tend to be lazy when you see the video. It's like an hour or 2 hours. I don't know why, but yeah. Let me stop it here. I'll see you in part 2.